All right, good deal. Thank you for the ping.
Good morning.
Good morning. Let's see. Could we go over how the autograder works on this latest ODP that was due? I got mine working perfectly as far as I could, but still got 0 out of 10 in every test and have no idea why. I tried swinging my office hours. Yeah, office hours got crazy really fast. It went from like 2 people to 10 and then to 14, like super quickly. Let me see. So, so let's talk about the ODP that was due 2 minutes ago. So I can show you some code that works for that, but what I want to do is try to understand why this code works and try to figure out how we can move towards this code when we're writing an ODP. And so as I said yesterday, all the ODPs this week are going to be similar. They're all going to be related to string processing, and so we'll be doing the same kinds of things from assignment to assignment. But let's take a look at 414, and I'll address this question in a direct message. You'll see what the issue was. What was the third test case? The third test case, I believe, was an empty string. And so a string of length 0, and you have to be really careful how you do that. The output string should be a string of just length 0. And depending on how you do your iteration, that can be different. So reminder on the README, right, you're taking 2 strings in, you're interleaving them, alternating characters, and then you're copying the interleaved string into an output string, which should be null terminated. So this was the kind of thing we worked out in class, right, where we had an output location, and then we iterate across all the characters in one of your strings, and it doesn't matter which string we use because the strings are the same length. So I could have used S1 or S2 here, right? And as I iterate through, I read the next character from S1, I copy it to the next output location. I read the next character from S2, I copy that to the next output location. And so at the end of this loop, all of the characters from S1 and S2 will have been stored in this output string, and outloc will still be the location where the next character should be written, and so that's where the null terminator can go. Now you could also do this by outloc bracket 2 times inloc equals S1, and outloc 2 times inloc plus 1 equals S2. That was the other way we developed in class. And then at the end, out bracket string length times 2 would be where the null terminator goes. And so direct message to me, it looks like you were iterating up to 2 times the string length instead of just less than the string length. And so I think you were copying too many things into the output string, and that might have been seg faulting. Let's see. And yeah, so these equal signs are assignment statements. An equal sign says take this on the right, copy it into this thing on the left. Right? So the assignment goes from right to left. And as I told someone in office this morning, my first programming language that I learned, assignments were actually done with an arrow. And so you would write a statement like this, and it said take this value and copy it into X. And the equal sign is ambiguous. It's not clear which way it's copying, but it's still the same sense. So when you say, A equals B, you can think of it as this. Read this and copy it into there. And so the order is...
basic or Fortran?
This?
Yeah.
That was an old programmable calculator called an HP 9820. and it had an arrow key on it, and it would display like that. Most languages don't have a character for an arrow; they use ASCII, so that's why we use an equal sign instead. But it's a little more ambiguous.
Neat.
Yeah, that was a cool little machine. All right, so let's see. So if you're looping through your input string with I and you're trying to copy out 2 times I and out 2 times I plus 1. One thing that came up in Office today was trying to do this. This is just not valid C syntax. It's exactly the right idea. We want to take 2 times I. But in C, you can't just say 2I if you want to multiply I by 2. You got to include the asterisk. That's just the way the compiler is told, hey, I want to multiply something by 2.
Which ODP is the next one?
416. All right, cautionary tale. In developing your code for this, right, we want to iterate over the characters in the string, and I've mentioned the usual way that I do this is something like this. Right, with a for loop, initialize I to 0, continue as long as I is less than the length of the string you want, and increment I at the bottom of the loop. And so this will go over, you know, elements 0, elements 1, all the way up to and including element string length minus 1. So if your string is hello, this would iterate for I equals 0, 1, 2, 3, and 4. If your string is hello, your string length is equal to 5. So if I say continue while I is less than string length, it will definitely do the iteration for I equals 4. It will not do it for I equals 5. And this is honestly the only way I've ever iterated over a string. But someone in office hours this morning was using string length minus 1, and so I suggested that you could also do this, right? So from I equals 0, I is less than or equal to string length minus 1, I plus plus. And logically this should work, right? If string length is 5, string length minus 1 is 4. Well, iterating from I from 0 up to and including 4 should be the same as iterating from 0 as long as you're less than 5. This does not work, right? This is a problem. And let me show you what can happen.
Is the tilde one basically substituting what like one of the input strings?
So sorry, say the beginning of that again.
The tilde and as in the parentheses of string length,
that's whatever your variable name is.
Okay.
So here's a harmless looking piece of code, right? I have an unsigned integer, and it's called I, and I set it equal to 0. And the thing to know here is string length returns what's called an unsigned integer, because the length of a string is never negative. So if you don't care about negative numbers, you can use an unsigned int and have a larger possible integer. So string length returns an unsigned int. So here's an example where I have an unsigned int I equal to 0, and then I set I equal to I minus 1. Well, 0 minus 1 should be minus 1, right? So I say if the new value of I is less than 0, that's good. If the new value of I is bigger than 0, that's bad. Right? And guess what? If I run this, it tells me it's bad. So 0 minus 1 is bigger than 0. And that's a little goofy. But it's because if I is an unsigned integer, 0 minus 1 is that bit pattern that represents -1, which is a bunch of ones, but treated as a positive number. And so it's like, 2 billion. And so this is tripping up this for loop. Because when you do string length, that's an unsigned int. When you subtract 1, that's, 2 billion, and this is going to iterate over 2 billion characters in your input string. And if your string is empty or anything else, it's going to run into a seg fault. Yeah, you're welcome. And you can also just check for a null terminator. So you could say, well, string bracket I is not equal to the null terminator, and then you're not interacting with string length. But this was a quirky thing to me that I hadn't encountered before, and so that was baffling. Let's see. Can you explain? I made an index. Index a string up to string I equals null terminator. Yeah, that's good. Good. And then put a null terminator for outlen right after my loop. That's good too. Yeah.
So I have a question. So were we supposed to put like a conditional inside our for loop or whatever, saying or right before our for loop, saying just add a null terminator if the string length of one of the input strings is 1.
You shouldn't have to. So at the end of your for loop, right, you can do a couple of different things. You could say output bracket 2 times string length of whatever your input string is, and set that equal to the null terminator. And if your string is HELLO, your output's going to have 10 characters, which will be in position 0 through 9, and your null terminator would go in position 10. And so if you work through some examples, 2 times the string length of your input string, that's where the null terminator goes. But if you do this idea of keeping track of your output location, right? If I never loop through this, if my strings are empty, when I come out of here, my output location is 0, that's where I put the null terminator. If my input strings have a single character, output loc starts at 0, this will make it 1, this will make it 2, my null terminator will go in position 2, which is again the correct thing to do.
Right there is pretty much what I did. I'm asking in the case of one of the input strings being an empty string.
If the string is empty, then this for loop will never iterate. And so when I come down here, my output loc will be 0, and output element 0 will be the null terminator, which makes the output string an empty string, which is the correct thing. But if you do less than or equal to string length -1 for an empty string, this loop runs 2 billion times. And that's why it's not assessing correctly. It also looks like you mixed some variables. You got an out loc and you got an out len.
Are you talking about mine?
Yeah, I think I lost my microphone window. All right, other questions? All right. Let's see. So the purpose of these ODPs are to give you some practice with some sort of concept. In this case, we're working with, you know, devising algorithms to manipulate arrays of characters in particular, but in general arrays. As programmers, right, you're going to be primarily creating algorithms, right? Programmers aren't really about writing programs, right? Being a programmer is really about coming up with an algorithm. Once you have an algorithm, converting that into C or Java or Python or whatever, right, starts to become more or less automatic. In fact, it becomes something that, you know, might get passed off to somebody else. Your real kind of value add to a client is coming up with algorithms, right? Coming up with a way to solve a problem. And then, you know, if you actually write the code, you've got, you know, your 10,000 hours of coding behind you, you can bang it out, you know, on a keyboard and have a working function or something, right? But it's really about coming up with algorithms. And that's a lot of what these ODPs are about, especially at this part of the course, right? Are thinking about how do I describe what I want the computer to do, right? And then, yeah, there's definitely a lot of detail involved in writing a program to do that. But we wanna mostly concentrate our efforts on, you know, what would be a reasonable sequence of steps to accomplish, you know, interleaving two strings or removing all occurrence of a character from a string or something like that. And there's a ton of ODPs in this course, and they're all worth the same amount. And, you know, if you have trouble with one of them, you lose, you know, a fraction of a point in your final grade. But getting, you know, 100% on the ODP is really not the point, right? The point is to get the practice with the algorithms, and that's way more important. You know, figuring out the algorithms, being able to do that, and getting a 0 on the ODP is going to leave you in a much better place than you know, getting an ODP to work but not really understanding why it works, and not understanding why what you were trying to do wasn't working. Right? So I just want to encourage people to, like, work these problems, right? And especially in a week where we've got all the ODPs posted, right? Try to work ahead, so that you have time to try the problem and then, you know, ask questions about it, and so on and so forth. And stay away from this stuff, right? This is deadly. I got this exact code from 5 different students, right, for ODP 414. And, you know, I'm not going to send people to the honor board over an ODP assignment, right? The ODPs are these like calisthenics, and it's like, you know, cheating when you're doing push-ups by you know, keeping your butt in the air or something, right? It's not something that I'm fundamentally worried about, but you're losing the whole benefit of the ODP if you look at a solution and turn that in, right? And this, you know, is completely unnecessary because you've been told the strings have exactly the same length. So why would you check to see if either one of these is equal to the null terminator? Well, both these conditions will be true at exactly the same time, right? But if you're in an interview and somebody's asking you to do something like this and you write something like this, they're going to wonder, well, why are you checking both of these conditions when, in fact, you know, you should understand that if one is true, the other is true, and you're just asking the CPU to do more work, right? Why are you returning the length of the output string when you haven't been told to return the length of the output string? And so you know, delete your Chegg account, right? I mean, it will lead you into bad places, and, you know, sooner or later there's going to be an action against Chegg, and all the records and accounts are going to come out, and you don't want to get caught up in that mess. It's a useful place if you're really trying to, you know, get help with homework and stuff, but it in most cases, students have told me it's really hard use sites like this and not fall into the trap of kind of like, you know, I don't have time for this, I gotta get on to physics, you know, so let me just see how to do this. Okay, that makes sense, you know, and then turn that in. So I shouldn't say delete your Chegg account, but you know, just be really aware you're playing with fire, and on the programming assignments, right, on material for exams, things like that, right, this is absolutely a huge deal. And if I got something like this, you know, on an exam, it would be an honor board thing, and that's just not something we want to be dealing with. So anyway, wanted to mention that. So be careful of that. So let's go on to the next ODP. So let's look at 416. So 416 is a remove function. You're taking in two strings, just like last time. You have an input string and an output string, but one input instead of two. And what the remove function should do is whatever the input string is, it should find all occurrences of a lowercase x and remove them from the output string. So if, for example, your input string is, you know, something bizarre like that, your output string should be T-E-T, T-E-T, H-I-H-O-A-L. Right? Now you're not replacing the x's with a space or something, you're removing them. So if your input string is hex, your output string is HE. If your input string is WXZ, your output string is WZ. If your input string is X, your output string is, you know, just an empty string, just a null terminator. If your input string is a bunch of X's, your output string would be just a null terminator. If your input string is A followed by a bunch of X's, like this, your output string would be ABC.
Do we have to account for a capital X, or is this just lowercase?
This is just a lowercase x. So again, the question is now, right, how would we describe this to somebody? You're going to hand this string to somebody and you want to give them instructions so that they hand you back a piece of paper that contains this. And we could say, hey, you know, delete all the x's and rewrite the string, but that's not going to work for a C compiler. So what are the steps that you would describe to somebody so that whatever string they have in front of them would end up looking like, you know, that original string without the x's?
I mean, it's pretty small. You could just do a sequential search.
Okay, how would you do that?
Just iterate a for loop, iterate each item, and then you get to a non-x. Check if each element is a x or not. If it's not an x, then put it in another array.
Okay, I like that. So iterate over each character from the input. If it's not an x, put it in the output. So this is something that we can start to work into an algorithm, right? So iterate over each character. So there's an A, it's not an X, let's put that in the output. Here's the next character, it's an X. It is an X, so we won't put it in the output. There's an X, we won't put it in. There's a B, it's not an X, we'll put that in the output. There's an X, we'll skip it, skip it, skip it, skip it. There's a C, it's not an X, we'll put that in the output. And then we're done with our input string. And so maybe I'll add an extra statement over here, which is put a \0 in the output. So we add that \0 on the end. Does that seem reasonable so far?
Yes.
So far.
Okay. So how do we iterate over each character from the input? So let's just think about this
You
part.
just use strlen to run a for loop over the input.
Okay. So let's
And-
say this is remove. And we'll have an input and we'll have an output. And this will sort of look like C, but it'll also be pseudocode. So let's make a for loop. So what do we want to call our variable?
I.
Let's call it I. It's going to start at 0 because the first character in our string is index 0. And then if we want to go through every character, you could do I less than string length of your input. And the third part of your for loop is what to do at the bottom of your loop, which is I equals I plus 1, or just I plus plus. So this will certainly go over each character of our input. And if we're not sure, right, we can test this. Right, so write some test code, right? Let's go from 0 up through I less than string length in, and let's print out character and print out the value of I is, and let's print out in bracket I, and we'll put it inside angle brackets, so we can see where the character actually begins and ends.
You need string.h.
Yeah, I do need string.h. Thank you.
How did you open that back up so quickly?
I had a,
You clicked up. Never mind.
yeah, I got 2 windows going here.
Oh, I see.
Alright, so we can compile this and we can run it, and you know, it looped 5 times with our index going from 0 through 4. And it told us HELLO. And if I had done, you know, I is less than or equal to string length, then we can see it loops 6 times, and the last character it gets is this funny, you know, non-existent character. It's a null terminator. If we want to do something with this in our loop, we could loop, you know, less than or equal to string length. But if we only want to iterate over the actual characters up to but not including the null terminator, then string length minus 1, so I less than string length. And here's this funny business: if we go less than or equal to string length minus 1, that also works, except if our string is empty. In which case it goes kind of nuts. So your safest bet is this, but we could also do this. Right, we could do a while loop. Initialize your index to 0, and then while element I of your input is not the null terminator, go ahead and print out I, print out the character, and increment I. and that'll work perfectly well. So you can always write code for, you know, part of what you're trying to do if you have any questions about it, or if something doesn't feel like it's working right. Go ahead and write a piece of code to test, you know, as you're developing the bigger program. So this will iterate over every character, and so we're saying if it's not an X, let's put it into the output. So we could say, you know, if input bracket I is not equal to X. Right? So in bracket I, that's the ith element. Exclamation equal is not equal, and we're looking for a character, so we need a single quote X. And so if this is not equal to X, then we want to, you know, put this character in the output. So how do we do that? How do we put this in our output string?
You can have another iterator, like J or something, and then have that increment every time something is put in the output string.
Okay, sounds good. Let me do an integer, and instead of calling it J, let me call it output location. And I'm going to initialize it to 0, and I'm going to say save next car at this index. So if we want to copy input bracket I to our output string, I'm going to say out bracket output location equals input bracket I. That will copy our character into the next spot in our output, and then I'm going to increment output location so that the next time we get to this statement, it puts our character into the next spot in the output. And I could also just put the ++ inside here if I wanted. But the goal is, after we copy this, let's increment output location. And then when we're done, right, so if output location started off at 0, after we write this, it'll be 1. After we write the B, it'll be a 2. After we write the C, it will be a 3. When we come out of the loop, then this 3 would be 0, 1, 2. It's the index of this spot right here. This is where we want to put the null terminator. So here we could just do output location, and put the null terminator there. All right. Is it bad practice to use something like while in bracket I is not equal to \0? You can get away with also doing this. And this will do exactly the same thing, right? Because in C, if you have an expression that evaluates to an integer, any value other than 0 is considered to be true, 0 is considered to be false. So if I write a statement like this, this is basically saying if this element I of the input is anything other than 0, let's go ahead and loop. And when you hit the null terminator, in bracket I will be 0, this while will be false, and it'll kick you out of the loop. So this is equivalent in behavior, and it's not a really bad thing to do. It can start to lead you down a slope of writing code that may be a little harder to read, but this is one shortcut in C that most programmers are pretty comfortable with reading and writing, to just say, you know, if X, as a shortcut for if X is not equal to 0. The only reason I kind of tend to prefer this is because we're not really looking for a 0 non-zero. We're really looking for a null terminator. and I kind of like seeing that there to remind me that this is a character, but that's perfectly fine. I don't think that's bad practice at all. And then somebody else suggested if you were to loop up to I less than or equal to string length, and if you do that, what's going to happen, you're going to also include that last character that comes after your final character, right, which will be the null terminator. And so if you did I less than or equal to string length, the last time through that loop, in I will be the null terminator. It's not an X. It'll get copied to your output. You never need to put this statement here. And so that's a nice embellishment also. So those are some possible embellishments on that algorithm.
So the if statement looks for zeros or nulls, and that'll trigger a false.
So yeah, so if you say something like, you know, if X, it really means if X is not equal to 0. And if you say,
well,
wow.
Isn't there also other falsy values, like empty string or, you know, empty array in some languages, or empty object phrases in some languages?
If it translates to an integer, it's either 0 or not 0, and 0 is false, non-zero is true. That's in C and maybe some other languages. Now, like Java won't let you do that. Java, if it wants a Boolean, it won't interpret an integer and treat it as a Boolean. But older languages, that's pretty common practice.
Oh, and because null is the ASCII code for 0, that's why it works. Okay.
Yeah, so the null terminator is ASCII code 0. Null is something different. Null is actually a pointer, and we're not going to worry about null until winter quarter, and then we'll worry about it a lot. EOF is something totally different. EOF is just a symbol for -1, and that's just a convention used by things like fgets or getcar, not fgets. All right. So all of our ODPs basically let us do something like this, right? Think about an algorithm, and try to describe it in some sort of, you know, set of steps, and then try to make those steps simpler and simpler until you get to a set of steps that you can explain to a C compiler, because C compilers are not very clever. Right, a friend, you could say, hey, just, you know, erase all the X's, and C compiler, you gotta like tell it exactly how to do that. All right, let me talk about grep. So some questions have started to come up around the calendar program.
I have a quick question.
Yeah.
So in Bash and Linux, arguments are taken in separated by spaces.
Mm-hmm.
Is there any way to change that so that each argument could be separated by something else other than a space, so that you could have spaces in your arguments?
So, what kinds of things are you passing these arguments to, for example?
So basically, in this in PA4, you want to see you know, all the appointments for a day.
Mm-hmm.
If I want to create say a list so that you can then, you know, select an appointment, I have to, you know, dynamically create that list, and in that list there may be spaces in the descriptions / name of the appointment. And so if I pass that to the dialog, it'll take the space in the description as like the next word will be like a new argument instead of part of the description.
So if you have a description, like this, right? You should be able to do dialogue. Like this, and have it remember the spaces in there. But you got to put this thing inside quotes, and if you don't, then you get, you know, some weird thing because it seems to think you have 7 tokens. But doing this inside quotation marks can get confusing, right? In particular, if I tried to have a string that looked like this and then execute that string by putting it inside, you know, $paren or something, these quotation marks can get gobbled up.
So the problem isn't with like info boxes and stuff, it's when radio lists need like an off and on as well as other options for every single item of the list.
Right.
And so if you have a space in your description, it'll push that option into the next like, you know, line, or yeah, to the next line, and then it will take, like, say, you know, the description of test space test, instead of doing, you know, test space test as the description and then off as whether it's on or off, it'll just do test test.
So like in a radio box, if I'm calling my first thing first, if I put that inside quotation marks, and double quotes should work here also, I should be able to embed spaces in that.
Right, but how would I do that in a dynamic string? Because I'm generating that first A off, default B on, last C off thing dynamically using a for loop.
Okay, so you can put a backslash in front of your quotes, and sometimes that will help. Right, so if I do x equals quote and I say backslash quote, instead of ending my string, this is just the quotation mark character, followed by A space B space C, quotation mark, and now if I look at the value of x, it includes those quotation marks. And then if I use this as an argument to, you know, my dialogue command, those quotation marks would get included. So try escaping your quotation marks.
Okay.
So let me make a bogus calendar here. All right, so here's a calendar data file, right? That might have been created by my PA4. So Nick has 2 appointments on the 8th, and Bob has an appointment on the 9th, right? And let's say you want to find all the appointments that are coming up on November 8th, right? So there's this command grep, which basically lets you search. And if I search for 2021-1108 and I put in the name of a file, grep will read that file and it will print out any line containing this pattern. And so if I just grep for 2021-1108 in cal data, I get all the lines that correspond to appointments on that date. And let's say I want to delete something. There's a switch you can put on grep, which is -v, and -v reverses what grep does. It shows you all the lines that don't contain something. So let's say I want to delete all of Nick's appointments. If I say grep -v Nick from cal data, it'll show me all the lines that don't contain the string Nick. And if I want to delete Bob from there, I can search for any line that doesn't contain Bob, and it shows me Nick's appointments. And so in your script, if I wanted to, you know, programmatically delete Nick's appointments, I could do something like this, and I could put this into caldata.temp, and then I could take this file and I could copy that on top of caldata. And now I've removed Nick from the calendar book. So when you're ready to delete appointment, grep and grep-v are really useful, especially if you use a temporary file like this. And again, you know, you might want to put this in the same directory as your calendar data, so something under /temp/calendar/ whatever. But you know, you can look for appointments using grep. You can look for everything that doesn't match an appointment with grep-v, and that's probably the easiest way to delete appointments. So that's something to keep in mind. If you put pipes around everything, we can be a little more careful about this. So if maybe I have you know, eat something with Bob. Well, if I just search for Bob in my cal data, this mistakenly brings up an appointment for Nick, because, you know, in the description of my appointment I had the word Bob. But if I want to search for just appointments belonging to Bob, I could do something different. I could search for a pipe Bob, right? And that's only going to find things that include this particular field, which will only be things that correspond to Bob's appointments. So adding appointments, right? You can use dialogue. You can get the date of the appointment, the name of the person if you want, the description of the appointment, and so on. And to add that to, so let's make a new appointment. This is going to be, you know, Jeff, and Jeff is going to open presents, right? So here's the line that we just built up from our dialogue command. If I want to add that to my calendar, I can just say echo new appointment, and then greater than cal data, and that will echo this new line, but it will take the result of that and add it to the bottom of my cal data. And so now I've got, you know, a fourth appointment in here. All right, so we're out of time. Send me an attendance note, and I will see you tomorrow. If you're getting a seg fault when you do a car star, this is just a question in chat. I'm responding to. When you say car star out, you're not actually initializing what out is pointing to. You're saying out's going to point to a character, but you're not telling it where to point. And if I try to, you know, look at string length of out or copy something into out bracket 0, I'm going to get a seg fault. Right? Now if I say car out bracket 120, out is still a pointer to a character, but it's also initializing out to point to somewhere in memory where there's 120 bytes available. And now if I look at out bracket 0, I'm looking at, you know, say this location in memory. If I do this, out is probably 0, and it's pointing to, you know, somewhere that doesn't exist probably, and so when I do out bracket 0, I just get a seg fault. So when you're wanting to have actual space corresponding to a string, you have to usually specify the size of it, or get into malloc, which we're not going to do for now. All right, you're good to go. I just got your final attendance ping, so you're good to go. And yeah, that string length thing was fun to work through. That was definitely interesting.
Have a good day.
All right, thanks. You too. I'll catch you all tomorrow.
Great day.